So this final problem, we are again using this little note card. We have our degrees Celsius to kelvins conversion, and then we have 3 different formulas we can choose from. So to start out, I'm just going to read through my problem and sort out what measurements I have. Okay, so a sample of helium has a volume of 45 milliliters, so that's going to be our volume, a pressure of 1 atmospheres, and a temperature of 18 degrees Celsius. So already we have 3 different values of 3 different variables. We know one of these is going to be constant. Okay, so one of them is not going to be used because all of our formulas up to this point only have 2 variables being used. Okay. So assuming pressure is constant, so I'm just going to cross out the pressure because that's constant, so we don't care about it. What is the new volume if the temperature increases to 23 degrees Celsius? Okay, so I do have temperatures in degrees Celsius, so I need to use my conversion. So I'm just going to add 273 to each of those values. So 18 degrees Celsius becomes 291 kelvins. 23 degrees Celsius becomes 296 kelvins. And now I can go ahead and just organize my variables. Okay, so we have 45 milliliters at 291 kelvins. So that's our initial. And then for the next one, we do not know the volume, but the temperature is 296. So now I'm just going to write out my formula. So V1 T1 is equal to V2 T2. So V1 T2 is equal to T1 V2. I want to get V2 on its own. So V2 is equal to V1 T2 divided by T1. And we just plug everything in. So volume 1 is 45 milliliters. T2 is 296 kelvins. And T1 is 291 kelvins. Kelvins cancels out. 45 times 296, and then divided by 291. And we end up getting 45.77 milliliters, always rounding to the 100th.